Imagine this. Traveller somewhere in the quiet space between thought and sleep, you find yourself drifting toward a story you were never meant to miss. As if the universe placed a hand on your shoulder and guided you here to an object gliding past the edge of Mars silent fast, and carrying secrets older than our sun. What are the odds, you wonder, that a single visitor from another star would follow a path with a 1 in 20,000 chance of happening by accident, and still arrive exactly where we could see it? Tonight we ask a gentle question. What if the first images from Mars revealed more than one object? Or a light that flickered once and never again? Let's drift a little deeper. Traveller tonight. The universe whispers again, not with thunder, but with a quiet flicker in the Martian sky. It began without intention, with an astrophotographer named Stephen Burns sitting at his computer, calmly reviewing raw images from the Perseverance rover. Nothing in his routine suggested that he was about to touch the edge of a cosmic question. He was merely stacking 9 minutes of night sky photographs, watching the stars drift as Mars slowly rotated beneath them. Yet there, cutting across that gentle motion, was a streak moving at 60 kilometers per second, an object brushing through the darkness, with a speed almost nothing in our solar system maintains. A line of motion where no line should be. He shared the animation, and the sky slowly woke. Other observers stabilized the frames, adjusted rotations, and noticed faint points of light trailing in strange directions, tiny anomalies moving in ways no background star should move. Some dismissed them as artifacts, others insisted they were real. The debate, like all debates born in the dark, grew without resolution, but one detail escaped argument. At the 3-second mark of the time-lapse, a soft green flash bloomed briefly and vanished. It was not a cosmic ray strike, not a glitch, not a pixel misbehaving. It was a diffused light, gentle and brief, but undeniably present. In space, green light has rules. It usually traces back to oxygen or dicarbon, the molecule that gives some comets their emerald glow. But spectroscopy from the Very Large Telescope revealed that 3I Atlas contains almost no dicarbon at all. The object is chemically depleted. It should not glow green. Yet telescopes captured a faint green haze around it in early September, and now Mars has recorded the same impossible colour. A single anomaly is a curiosity. Two begin to form a pattern. While observers studied Perseverance's images, attention quietly shifted to the orbiters circling Mars. NASA had prepared for this moment. HiRace Mars Express and the Trace Gas Orbiter had all targeted 3I Atlas during its flyby. These were not routine photographs. They were coordinated, high-priority observations designed to produce the clearest images ever taken of an interstellar object passing through our system. HiRace, capable of resolving stones on Mars from orbit, should detect 3I Atlas at 30 million kilometers. Even a 5-kilometer nucleus would appear as a cluster of bright pixels, and then silence. No raw frames, no previews, no early releases. NASA announced only that the data was being processed. ESA, free from US administrative slowdowns, also released nothing. 2 agencies, 2 independent pipelines, 1 synchronized quiet. Meanwhile, the anomalies deepened. When analysts stabilized Burns' animation, compensated for Mars rotation, and removed noise, multiple fast-moving points remained visible in some frames. Not clearly defined, not easily categorized, yet persistent enough to raise the question, are we seeing fragments companions or simply tricks of pixel and motion? No answer satisfies everyone. Still, the most important certainty remains simple. Perseverance saw something. Something fast. Something bright. Something green. And now that object is slipping toward the sun into a region where telescopes cannot follow. By late October it will vanish behind the solar glare entirely. Only the sun will see it. Only silence will hold it. When it emerges, perhaps in November, perhaps in December, it may reveal nothing unusual. Its path may match predictions, its light may behave normally, its chemistry may remain consistent with rare but natural comet physics. This is one possibility, clean and comfortable. But another possibility lingers quieter, yet harder to dismiss. The anomalies could align. The missing data could matter. The green flash, the chemical contradictions, the hints of multiple objects, the coordinated silence, all could form the beginning of an unexpected story. Science asks us to wait before we believe, but wonder asks us to listen. For now, traveller, we stand in a familiar interval, the pause between observation and understanding. A place where evidence is incomplete and interpretation feels fragile. A place where the universe invites patience, not conclusions. It is here in this quiet uncertainty that astronomy becomes something more than measurement. It becomes meditation. Perhaps the anomalies are noise. Perhaps the silence is procedural. Perhaps the object is simply an unusually large, unusually fast, unusually complex interstellar comet making a brief visit to our sun. Or perhaps somewhere beyond our reach, something ancient still moves with purpose we cannot yet name. Whatever the truth, you are safe to wonder. You are safe to not know. The universe has always revealed itself slowly. Rest now, observer. Some mysteries aren't meant to be solved, only witnessed. Sleep, the cosmos will keep watch. The silence around Mars did not begin with a dramatic announcement. It began with a missing upload, a simple absence in a place where images usually appear without hesitation. In normal times, Mars gives us everything quickly. Orbiters send new photographs almost daily, each frame, passing through the familiar rhythm of calibration, correction and release. But this time the rhythm broke. And in that pause, a different kind of question began to gather. Space agencies rarely offer mystery intentionally. When the universe behaves predictably, data flows like a river. It moves cleanly through channels built over decades. Scientists draft their notes. Press officers prepare summaries. Amateur sky watchers download raw frames before the ink has dried. Everything moves calmly and transparently. But when something unexpected enters those frames, the stillness begins. NASA mentioned only that the data was being processed, a phrase that explains little and reveals even less. ESA, which is not tied to the same bureaucratic slowdowns, offered no comment at all. Two agencies, two sets of instruments, one shared silence. And because silence is unusual, it becomes a kind of data too, the kind that makes observers lean in, wondering what could justify the delay. Meanwhile, amateur astronomers continued working with the tools they had. They downloaded Perseverance's publicly available images, the same ones Stephen Burns used. They stabilized the sky, aligned the stars, and watched as a streak cut across the Martian night. 60 kilometers per second, slicing through the dark like a blade of cold light. Some saw hints of other moving points, faint and uneven, drifting at strange angles. Others dismissed them as artifacts of stacking, the kind of digital illusions that appear when software tries to force clarity out of noise. Yet no amount of debate could erase the certainty at the centre. The rover captured something fast, bright and real. The orbiters should have seen it more clearly. HiRISE can resolve stones on Mars from orbit. Pointed at an interstellar object, it should distinguish fragments from a single nucleus. Mars Express and the Trace Gas Orbiter should reveal composition, structure and activity. These instruments were built to reveal secrets, not hide them. And yet nothing. Some explanations are simple administrative delays, calibration bottlenecks, bandwidth limits, staffing shortages. These are real constraints that shape even the most advanced missions. But when two independent agencies show the same hesitations at the same moment, the explanations feel thinner, stretched across a wider and stranger silence. Another thread appeared quietly, almost unnoticed. An astrophotographer named Simeon Schmaus claimed a faint detection from October 1st one day before the Burns sequence. The object's motion, he said, was slightly off close to predictions, but not entirely aligned. It could have been error, it could have been truth, but before anyone could verify it, he stopped speaking altogether. Not a correction, not a follow-up, just absence. Patterns form even in coincidence, and in astronomy, coincidence is often the beginning of discovery. Now the object drifts closer to the Sun, slipping into the region where cameras cannot safely look. The glare will consume it. By late October, the comet will pass behind the solar disk, vanishing into a brightness so extreme that even space telescopes must look away. For several weeks, we lose it completely. Every scientific uncertainty deepens when an object moves into that kind of darkness. Comets often transform during perihelion. They fracture, they brighten, they release hidden ices, they shed layers that remained quiet for billions of years, or they survive unchanged, moving through the fire like a stone through wind. When 3i Atlas re-emerges, something about it will be different, whether subtly or profoundly. Brightness will be the first clue, trajectory the second, composition the third. Even a small deviation could reshape our assumptions about the object's nature. The laws of physics do not panic. They simply wait for more data. And yet, here on Earth, the waiting feels heavier than usual, because this comet carries anomalies that do not align neatly with the natural explanations we prefer. Green flashes without the molecules that create green light, metal emissions without the expected companions, a trajectory that brushes past planets with uncanny precision. A mass far larger than predicted for an interstellar visitor, a record of radio alignment with the famous 1977 WOW signal. None of these details prove anything extraordinary, but together they create a shape that natural explanations struggle to contain. Still, astronomy teaches humility. The universe has more ways to be strange than we have ways to imagine it. A comet can be odd, very odd, and still be nothing more than ice dust and time. For now, the question sits unforced. We watch, we wonder, and we wait for the sun to give the object back to us so we can measure what changed in the fire. These weeks of silence are not a threat. They are simply part of the sky's long, breathing cycle. Every object that passes near the sun enters this temporary blackout, a corridor of invisibility where even the most advanced observatories must bow to light. When 3i Atlas returns, we will see it clearly again. We will refine our questions, we will compare its pre- and post-perihelion form, and the universe, patient as ever, will reveal only as much as it chooses. Tonight, traveller, let uncertainty rest lightly in your hands. Let the unanswered questions drift like dust at the edge of a comet's tail. Not everything hidden is ominous. Sometimes silence is simply the universe thinking, sleep now. The cosmos continues its slow ancient work whether you're watching or dreaming. The WOW signal began quietly, almost shyly in 1977. A single burst of radio energy printed onto paper, circled in red ink and left hanging in scientific memory. For decades it was a whisper with no echo. Astronomers searched the same region of sky again and again. No second signal appeared. The silence made the original detection feel even stranger, like a message sent once and never repeated. Then Avilob asked a question that shifted the ground beneath the mystery. He traced the orbit of 3i Atlas backward, not days or months, but 48 years. He wanted to know where this interstellar object was on the night of the WOW signal. The alignment was unexpected. 3i Atlas would have been within single-digit degrees of the signal's coordinates. The odds of such an alignment were roughly 1 in 170, unlikely, but not impossible. Alignment alone doesn't tell a full story. But it is enough to make scientists pause to wonder what else might connect two events separated by half a century. Sometimes a pattern begins with nothing more than coincidence. Loeb then calculated the power needed for a transmitter at that distance. The result was modest, by cosmic standards, about the output of a nuclear reactor, something within the reach of a civilization capable of interstellar travel. Another detail deepened the intrigue. The WOW signal showed a slight blue shift, meaning the source was moving toward Earth. 3i Atlas is also moving inward at a similar speed, about 60 kilometers per second. The numbers were not identical, but close enough to raise eyebrows. Close enough to keep the question alive, close enough to change the mood of the mystery. Yet astronomy demands restraint. The world is full of false patterns and illusions that feel meaningful. Natural explanations cannot be dismissed even when coincidences begin to stack like quiet stones. Still, something feels unfinished. This is the first interstellar object after 1i and 2i to cross paths with Earth, the only one arriving near the anniversary of a famous unexplained signal. And yet no major radio array is listening. Optical telescopes watch 3i Atlas closely. Spectrometers track its chemistry. Mars orbiters followed its approach. But the noise-sensitive ears that could detect a whisper the radio telescopes remain pointed elsewhere. This absence is subtle but strange. Not sinister, simply puzzling. It leaves the door open for interpretation. Meanwhile, 3i Atlas carries its own list of anomalies. A green glow without the expected molecules, nickel gas without iron, a forward jet instead of a tail, a trajectory that brushes close to planetary orbits with unnerving precision. Each detail can be explained naturally, but each explanation feels like stretching fabric over a shape it wasn't designed for. Nothing breaks the rules, but everything bends them. If the WOW signal and 3i Atlas are unrelated, both mysteries remain beautiful on their own. A strange comet on one side of time, a strange signal on the other. Two distant curiosities floating in the dark. But if they are connected even faintly, then the universe may have spoken to us once in 1977, and is now passing close enough for us to hear it again. A whisper followed by an arrival. We do not know which story is true. We may never know. But uncertainty is not a threat, it is a place to rest. There is comfort in the unknown. Comfort in the idea that the cosmos still holds secrets beyond our reach. Comfort in knowing that we are allowed to wonder without answering. You traveller are part of that wondering, part of the species that noticed a 72-second signal and spent decades holding it gently in its collective imagination. Curiosity is the quiet engine of your world. So let the questions remain soft. Let the possibilities drift like dust across a comet's halo. Let the unanswered pieces settle without urgency. Tonight there is no need to decide, no need to conclude, only to listen, to breathe, and to feel the vast silence that surrounds all things. Sleep now, traveller. Whatever the WOW signal was, the universe will reveal the truth when it is ready. Comets tend to follow familiar rules. When sunlight reaches them, they heat, slowly, release buried gases, and shed dust in soft, predictable waves. Their behaviour is ancient and steady, shaped by 1 billion quiet orbits. Nothing about them usually asks us to question the fundamentals of space chemistry. But 3i Atlas broke from that tradition the moment it began to glow. As it approached the inner solar system, astronomers detected a clean, persistent stream of nickel gas rising from the comet. This alone was unusual. What made it extraordinary was the silence of iron. In nature, nickel and iron are inseparable partners. They form together in stars, they bond together in dust grains, and they evaporate at nearly identical temperatures. Yet here iron was almost entirely missing. Night after night, the Very Large Telescope measured strong nickel lines and nearly no iron. The imbalance did not fade, it widened. Only when the object crossed a narrow distance threshold did iron begin to appear, and even then its presence was faint and chemically disproportionate. The ratio was unlike anything seen in comet science. Scientists did what scientists must do. They looked for explanations rooted in nature. One idea involved a fragile compound called nickel tetracarbonyl. Under the right ultraviolet conditions, it breaks apart cleanly and releases pure nickel gas. Yet this molecule is not easily created. It requires pressures and temperatures that are unusual for comets. On Earth, humans manufacture it in controlled environments as part of an industrial process. This similarity was uncomfortable. It did not prove anything artificial, but it complicated the natural models. Other hypotheses leaned on exotic nanoparticles, radiation-sculpted surface layers, or chemical segregation over billions of years in interstellar cold. Each explanation required a chain of rare circumstances, each stacking improbabilities in a delicate line. And then came the rate of release. At first, 5 grams of nickel per second, later more. Over time, the comet shed tons of nickel, even though its temperature should have been far too low for metals to vaporize at all. The numbers strained every known model. Attention turned to the comet's ancient origin. 3i Atlas likely formed around an old metal poor star billions of years ago in the Milky Way's thick disk. It drifted through interstellar space for ages, absorbing radiation and accumulating scars. But no scenario convincingly explained why iron would be suppressed so drastically while nickel escaped so easily. This prompted a different line of thought. Perhaps the nickel wasn't coming from the comet's interior. Perhaps it was being stripped from its surface. If the outer layer consisted of metallic dust, accreted debris, or some form of coating, natural or otherwise, then sunlight could erode it. Avi Loeb suggested the simplest speculative version. If the object were artificial, solar heating could vaporize a metallic skin and release nickel-rich gas. Critics countered that no advanced vessel would be made from materials that vaporize so easily. But such arguments assume the nickel is part of the structure itself. It could just as easily be residue, or shielding, or a deposit accumulated across billions of years, or even something shed intentionally. The debate remained suspended unresolved. Then Hubble revealed something that deepened the mystery even further, a plume of light emerging not behind the comet but in front of it. A forward-facing jet pointing toward the sun. Comet tails are pushed away from the sun. This is one of the most fundamental rules of comet behavior. Radiation pressure leaves no room for exceptions. Yet 3i Atlas displayed a bright plume pointed forward like a torch carried against the wind. Some suggested an anti-tail, a perspective trick that sometimes occurs when dust aligns with an orbital plane. But the geometry of 3i Atlas did not match the illusion. The brightness profile steep near the nucleus rapidly thinning outward was also inconsistent. This looked like material actively expelled toward the direction of travel. A material expelled forward creates drag, that slows an object. This raised the quiet question no one wanted to ask aloud: was the comet braking? Official measurements detected no non-gravitational acceleration, but the window of observation was small, and small thrust can hide inside the noise. If the object were adjusting its trajectory subtly, our current data might not reveal it yet. By this point, the anomalies had formed a cluster, a green glow without the molecules that create green, nickel without iron, a forward plume without a tail, a mass larger than expected for an interstellar visitor. A trajectory eerily close to multiple planetary orbits, a chemistry unmatched by anything we have catalogued. Each anomaly alone could be explained. Together they created a shape that resisted easy answers, and yet none of this forces a conclusion. The universe is vast enough to hide rare processes, strange chemistries, and unusual histories. Nature is not limited to our expectations. Tonight, traveller, the invitation is simple: sit with the strangeness without trying to resolve it. Let the unknown remain soft and unhurried. Let the comet be what it is, a question drifting through light. Mystery is not a threat. It is a reminder that we are still early in our understanding of the cosmos. It is permission to be small, curious, and calm beneath a sky that has always been larger than our knowing. Rest now. The universe will reveal its meaning in its own time. The deeper 3i Atlas drifted into the sun's quiet domain, the more its behaviour began to resemble a contradiction wrapped in dust and silence. In the cold mathematics of natural comets, outgassing is predictable. Sunlight strikes, frozen ice molecules escape, and the nucleus is nudged ever so slightly off its gravitational path. But with this object, the numbers refused to behave. Telescopes recorded vigorous outflow, tens of tons of gas released each day, yet the momentum of that release barely shifted its trajectory. It remained steady, massive, unbothered, as though it carried an anchor of impossible density. And when astronomers calculated the mass needed to resist such forces, they arrived at a figure so large it unsettled the models built to make sense of wandering ice: at least 33 billion tons, perhaps more. A miniature world travelling alone between stars, yet obeying none of the quiet rules we assigned to ancient visitors. This mass alone would have been enough to disrupt expectations, but 3i Atlas did not stop there. Its chemistry became a second frontier of unease. When the James Webb Space Telescope spread the object's light into its spectral components, it found a composition inverted from every comet observed so far: water. The ordinary backbone of cometary identity appeared only as a minority trace, while carbon dioxide dominated the volatile inventory at levels 8 times higher than expected. The reading suggested a birthplace far from any warm young star, somewhere beyond the carbon dioxide ice line of another system entirely. Yet even then the ratios were strange. No model of early planetary disks could easily produce such an extreme imbalance. The simplest explanation, that the outer layers had been chemically sculpted by cosmic radiation, during billions of years in interstellar space, answered one question only to raise 5 more. Radiation could alter surfaces, but not entire reservoirs of frozen volatiles. For such uniformity to exist, the object would need to have formed under conditions unlike any known nursery of worlds. Yet the chemistry deepened again with another anomaly. Nickel faint metallic unmistakable streamed from the coma without its natural companion element iron. In ordinary astronomical processes, nickel and iron appear together forged in the same stellar furnaces embedded in the same ancient minerals. To see nickel so strongly without iron was not merely unusual, it was chemically improbable. The compound that best matched the behaviour, nickel tetracarbonyl, is familiar not from celestial laboratories, but from industrial refining on Earth, where it is used to purify metals through controlled heating and decomposition. Scientists did not claim an artificial origin, but the echo of technological chemistry unsettled the conversation. If not artificial, then the object's surface must contain exotic compounds formed through pathways we have never witnessed. If artificial, then we stand before a different kind of question entirely, one we're not yet prepared to pose. The light around the object compounded the mystery. Hubble's images showed a structure that defied cometary instincts, a spear of faint glow extending forward toward the sun rather than away from it. Natural comets carry tails that are pushed outward by pressure and solar wind. This forward-facing plume, sharp and directional, suggested either a tightly focused jet of vaporizing ice or an emission process not powered solely by reflected sunlight. Some researchers proposed that ultrafine dust particles were escaping the surface only to be rapidly destroyed by solar radiation. Others suggested a rotational oddity, a nucleus whose sunward side outgassed violently, while the rest remained quiet. But even these explanations strained under the image's intensity. The forward glow fell off too steeply, too abruptly, as though the light was not simply scattered dust, but something being actively projected. A natural process could still produce this pattern, but the cosmic silence around it felt strangely intentional. Taken alone, any one of these anomalies could be dismissed as an outlier of nature's broad creativity. But taken together, the mass, the chemistry, the metal emissions, the inverted composition, the unnatural radiance, the object began to feel like a collection of exceptions orbiting a single unresolved truth. Astronomers often trained to distrust coincidence found themselves facing a constellation of them. How often does the third interstellar visitor ever discovered also become the strangest? How often does a statistical rarity arrive, bearing chemistry that challenges every model built to describe its kind? Logic suggested randomness. Intuition whispered something else. Even then, scientists remained cautious. The human mind, after all, has a habit of weaving intention into shadows. Yet the trajectory calculations added one more whisper of unease. The path of 3i Atlas did not skim planets by vast margins as comets typically do. Instead, it threaded itself through improbably close encounters, grazing Mars, then slipping toward a geometry that brought it within observational reach of nearly every active space telescope. The alignment could easily be coincidence, but sometimes coincidence gathers weight simply by repeating itself. And when Avi Loeb calculated the probabilities, he found that the object's path came far too close to several bodies to be dismissed as ordinary. He did not call it artificial. He simply said the quiet thing: we should not ignore the possibility. For now the universe offers no answers. The object continues toward perihelion, slipping deeper into the sun's glare, vanishing from our instruments just when we need to see it most. And so we wait. Travellers, observers, listeners suspended between natural explanations, stretched thin and extraordinary ones we dare not fully name. Perhaps 3i Atlas is simply a comet shaped by unusual histories. Perhaps it carries nothing more than ice dust and silence. Or perhaps in ways we cannot yet perceive it carries intention. Tonight it drifts behind the sun alone and unknowable. And all we can do is watch the darkness it leaves behind and accept quietly that some mysteries are meant not to be solved, but to be observed. For months, astronomers had expected 3i Atlas to behave like every other active comet approaching the sun. They anticipated a familiar pattern jets of gas pushing the nucleus slightly off course, causing measurable non-gravitational acceleration. Yet when the observations were compiled from over 200 observatories across the world, the data revealed something disquieting. The object moved with nearly perfect obedience to gravity, as if its immense outgassing exerted no meaningful influence at all. This steadiness suggested not fragility but mass, a mass so large that ordinary comet models began to fracture under its weight. In the mathematics of momentum, the only way for an object to shed tons of material each day without drifting even slightly was for its nucleus to be colossal. And so the calculations pointed toward an uncomfortable figure, at least 33 billion tons, perhaps far more. This mass implied a size unlike anything we have ever seen from an interstellar visitor. A body several kilometres across is already a rarity in our own solar system, but from the vast cold expanses between stars, such a behemoth should be extraordinary. So extraordinary that models predict we should have detected thousands of smaller objects before encountering one this large. Instead, the first two interstellar visitors were modest, faint and fragile. The third is a miniature world massive enough to swallow statistical expectations whole. When astronomers whispered that maybe the models were wrong, they did so with the uneasy tone of people realizing the universe is not required to follow our spreadsheets. This mass anomaly alone would have been enough to instigate debate. Yet, 3i Atlas continued to challenge assumptions by refusing to glow in the ways comets typically do. The James Webb Space Telescope captured carbon dioxide escaping from its surface at a rate that implied vigorous internal activity, and yet none of that activity translated into motion. Observers compared it to a mountain releasing steam while remaining perfectly still, a contradiction that made even seasoned researchers pause. Some wondered whether the nucleus was denser than expected, perhaps filled with rock or metal. Others proposed a more exotic idea that the outer layers were shedding, without imparting momentum to the interior, as if the surface and core were decoupled. But nature rarely divides herself so cleanly. What deepened the uncertainty was the absence of visible non-gravitational drift, a phenomenon essential to understanding comet evolution. When ice sublimates, the escaping gas behaves like thrusters gently altering the orbit. The fact that this effect remained undetectable suggested a nucleus more massive than theory predicted could survive interstellar ejection. You listener can imagine how such a finding unsettles the quiet corridors of astrophysics. It suggests that the galaxy may contain objects far larger, far stranger, and far more ancient than any catalogue has prepared us to accept. Even as scientists computed the object's mass, they also confronted the unsettling realization that its trajectory was unusually cooperative. Instead of sinking into the outer dark or slipping past unnoticed, it threaded through the inner solar system with uncanny precision, skimming Mars, drifting into the observational windows of multiple spacecraft, and passing through regions where nearly every major telescope happened to be watching. Coincidence is a patient companion of astronomy, but a chain of coincidences eventually begins to resemble a pattern. And so the murmurs began, was this simply chance? Or were we witnessing the geometry of something else? This question intensified when researchers mapped the statistical likelihood of the object's mass compared with its discovery. According to known population models, an interstellar object of this scale should be 1 in 10,000, a distant outlier among countless smaller fragments. Yet it appeared early in our era of wide-field surveys, as if the cosmos placed it in our path just as humanity's instruments became sharp enough to capture it. Some astronomers dismissed this as observational bias. Others felt something deeper, an ancient intuition, that sometimes the universe brings you a story precisely when you're ready to hear it. The mass estimate also fed speculation about the object's internal structure. If it was truly composed of loosely bound ice and dust, gravitational stresses during its long journey through interstellar space should have crushed it. For billions of years, collisions with dust grains and cosmic radiation should have chipped it away until little remained. Yet 3i Atlas arrived large, bright and clearly active. This resilience led some researchers to wonder whether the nucleus contained something more cohesive, rock metal, or even an internal architecture shaped by processes unseen in our own planetary system. Theories drifted between the natural and the extraordinary, but the truth remained hidden behind the glow of its coma. All of this would still fit, however uncomfortably, within the boundaries of natural possibility if not for what came next. When astronomers plotted the expected non-gravitational acceleration for an object with the outflow measured by Webb, they expected to see a deviation. But the measurements showed no such shift. Instead, the orbit hewed perfectly to gravitational predictions to within limits so tight that the object resembled not a fragile comet, but a controlled mass guided with precision. This silence between these numbers weighed heavily. Was it merely an exceptionally stable body, or was something unseen stabilizing it? This is the point, traveller, where the scientific narrative began to diverge from the comfortable. The mass calculations, the chemical anomalies, the strange tail geometry each offered a natural explanation. But when stacked together, they formed a quiet dissonance that could not be ignored. Perhaps it's only an extraordinary comet sculpted by rare histories. Or perhaps it is something older, something carrying stories from the dark between stars. For now, astronomers watch as 3i Atlas approaches perihelion, vanishing behind the sun's brilliance. In that silence, the universe thinks, and we can only listen. Whatever emerges on the other side, unchanged, fragmented, or altered in trajectory, will guide our understanding of what we have truly encountered. Until then, we wait. Quietly. Curiously. Sleep, traveller. The cosmos will keep watch. The closer astronomers looked at 3i Atlas, the more its chemistry refused to behave like anything drawn from the catalogues of known comets. When the James Webb Space Telescope illuminated its spectral fingerprint, the pattern didn't simply bend the rules, it rewrote them. The ratios of gases drifting from its surface seemed almost inverted, as if the comet were built in a place where the periodic table had grown its own dialect. Instead of water dominating its volatile inventory, carbon dioxide overwhelmed everything else, rising to levels that made researchers stare at their data twice, then a third time in disbelief. Water, the most abundant ice in nearly every solar system object we have ever encountered, appeared only in thin traces. At first, scientists suggested surface alteration, cosmic ray exposure, or exotic thermal histories. But the deeper the analysis went, the stranger the narrative became. Observers expected the comet's inner chemistry to reveal more familiar patterns as it warmed near the sun. Instead, the carbon dioxide remained astonishingly dominant. The absence of water meant something profound about its formation, as if this object had condensed in a colder, more distant region of a star system. Unlike our own, a disk where carbon dioxide froze, first forming a crust that shaped the whole identity of the body beneath. And yet even this theory felt too simple. If the object was born so far from its parent star, then how had it survived ejection, interstellar travel, and billions of years of cosmic weathering while retaining such purity? You, observer, can already sense the tension. Every explanation illumined something extraordinary, but none settled into the comfort of certainty. The brightness patterns in the coma only deepened the puzzle. As 3 Atlas drifted inward, astronomers expected the warming to produce predictable ratios of gases, carbon monoxide rising early, followed by water, then heavier volatiles, peeling away in the gentle hierarchy of sublimation. But the sequence was broken. Carbon monoxide was present, but strangely muted, as if trapped beneath layers not yet warmed enough to escape. Water clung stubbornly to dormancy. Carbon dioxide, meanwhile, surged outward, intensities far higher than expected, as if some interior reservoir were venting through pathways shaped not by nature's usual hand. Even more unsettling was the depletion of carbon chain molecules. Many comets emit dicarbon-tricarbon, and other carbon-bearing fragments producing the distinctive green glow that drapes many cometary comae. But 3 Atlas lacked these chains almost completely, and yet still showed hints of green in its outer envelope, as if some unknown process were triggering isolated emission lines. The absence of carbon chains should have extinguished that colour entirely. Instead, the object seemed to produce a faint signature without the molecules traditionally responsible for it leaving the scientific community in a quiet, baffled awe. Then came the polarization measurements, the kind of data that often hides in the margins of astronomy papers, subtle, easily overlooked but occasionally transformative. Light scattered from the dust surrounding 3 Atlas behaved in ways no comet had ever shown. The polarization was not merely low, it was profoundly inverted, almost as if the dust grains were sculpted from materials with optical properties alien to our system. Achieving such extreme negative polarization would require particles with unusual refractive indices, internal structures we do not see in other comets, or a geometry formed by processes we cannot yet model. Yet there it was a comet speaking in the accent of an unfamiliar cosmos. Some researchers asked whether the emission might not be dust at all, but gas fluorescence or even light produced by internal processes. The idea felt bold but not impossible. Fluorescent emissions have been seen elsewhere in the solar system, though never at this scale, never with this persistent clarity. Threading that hypothesis through the observations revealed something intriguing. If the glow were partly self-generated, it would naturally explain the steep brightness, fall off the absence of a normal dust tail, and the strange distribution of light around the nucleus. But even this idea opened another question: what kind of chemistry or energy source could create such a display? The mix of findings began to resemble a puzzle, with pieces from multiple boxes. Each fragment could be explained naturally, but assembling them into one coherent picture required extraordinary mental flexibility. A carbon dioxide-dominated comet might form in an unusual star system. A deeply processed surface could arise from billions of years in interstellar space. Exotic dust polarization might result from slow radiation sculpting over cosmic timescales. The green flash near Mars could emerge from rare dicarbon pathways. All of these are possible, and yet when placed together, the portrait no longer resembled a standard comet. It resembled something stranger, an object shaped by a recipe we had never tasted. Then there was cyanogen, a compound familiar in cometary chemistry, but usually accompanied by a suite of carbon-bearing molecules. In 3I Atlas, cyanogen appeared alone, decoupled from its typical molecular companions, like a message written in the wrong alphabet. The early detection hinted that the compound was layered near the surface, ready to escape with only gentle warming. But why would cyanogen survive while other carbon chains were depleted? The logic bent just slightly enough for the scientific imagination to tremble. Taken separately, every anomaly could be attributed to nature's creativity. Taken together, they formed a symphony of contradictions, an object composed of improbable harmonies. You can almost feel the collective breath of the scientific world pausing not in fear, but in recognition of the unknown. For this is what discovery feels like, the quiet hum of data that refuses to settle. The soft shiver that moves through a community when the universe reveals something that does not match the patterns we have grown comfortable with. And so researchers watch, listen and wait. The chemistry of 3I Atlas may yet resolve into a coherent natural explanation, revealing itself as an extraordinary but ultimately normal comet. Or it may remain a whisper from some distant unfamiliar system, a reminder that we are new to this universe, and much of its language is still untranslated. For now, traveller, it is enough to know that something ancient moves through our sky, carrying the stories of a star we will never see. It is enough to rest in the uncertainty, to breathe in the mystery without demanding resolution. It's all right not to understand. The cosmos is vast, and tonight it whispers again. By the time the chemical anomalies of 3I Atlas had settled into the collective unease of the scientific community, another question began to rise quietly from beneath the numbers. If this object refused to behave like a comet on the inside, would its motion through space reveal an equally unfamiliar truth? Observers expected turbulence, small wobbles in its path, subtle nudges imparted by jets of escaping gas. But what they saw instead was a stillness so deliberate it felt almost conscious. The trajectory of 3I Atlas clung to gravitational predictions with unnerving precision, as if the object were following a script written long before it entered our solar system. At first, astronomers welcomed the stability. Predictability is comforting in a universe that often prefers surprise. But as the days passed, the lack of drift began to feel like a silence too perfect to be natural. Comets, especially active ones shedding material at high rates, behave like tired travellers. They stumble, correct themselves, and drift slightly off track. But 3I Atlas did none of this. Its orbit held firm, unbothered by the constant shedding of gas and dust. It behaved not like an object being pushed around by sunlight, but like something heavy, deliberate, and anchored by its own immense mass. This led to a deeper discomfort. If the mass estimates were correct, at least 33 billion tons, maybe far more, then 3 Atlas did not belong in the statistical landscape of interstellar visitors. We should have found thousands of smaller fragments before encountering something this large. Yet the universe placed this object directly in our path at a moment when our instruments were finally sharp enough to see it. Some researchers whispered about luck, but luck rarely repeats itself with such symmetry, such purpose. And so another question followed naturally. If the chemistry was unlike anything we expected, and the mass belonged to a category we were not prepared for, then what exactly was this object doing as it approached the Sun? Because approaching perihelion is not a gentle experience. For a fragile comet, it is a trial by fire, a passage through intense radiation, violent heating, and stresses strong enough to rip nuclei apart. Many comets fracture, some evaporate entirely. But with 3I Atlas, no one knew what to expect. Would it erupt? Would it split into pieces? Or would it hold its shape like some ancient relic, accustomed to harsher suns than ours? The truth was hidden behind the solar glare. As 3I Atlas drew closer to the Sun, Earth-based telescopes grew blind. Instruments that had followed it for months suddenly found themselves staring into brightness. Space observatories too were limited. Hubble and Webb could not look near the Sun without risking their optics. A curtain of light fell across the object, separating us from whatever transformation might be unfolding. Astronomers called this the danger window, not because danger was expected, but because ignorance is a kind of danger when dealing with the unknown. For nearly 3 weeks, the object would disappear, entirely slipping behind the Sun like a traveller entering a chamber from which no signals return. What happened during that time would only be revealed after it emerged again. The silence felt long, heavy, and strangely intimate, as if the universe itself needed privacy to decide what story it would tell next. In the days before, the blackout scientists prepared a list of signs to watch for when the object returned to the sky. Brightening would suggest fragmentation. Darkening could indicate the shedding of surface layers. A shift in colour might reveal new chemistry exposed by solar heat. But the most important marker of all was trajectory. If 3 Atlas emerged on the predicted path, then perhaps the universe was simply presenting us with a rare, beautiful anomaly. If it did not, then the implications would be deeper than any telescope could easily explain. Meanwhile, Avi Loeb and his team continued to examine the numbers with a different lens, not one of fear, but of curiosity sharpened by centuries of scientific precedent. They asked a question humanity has always edged toward, but rarely allowed itself to confront directly: what if the object's behaviour reflects something that did not arise from natural processes alone? Not necessarily artificial in the way we imagine spacecraft, but structured, guided, or influenced by mechanisms beyond our current scientific vocabulary. The idea was not a declaration, it was a whisper, a possibility quiet and patient. After all, nature is capable of making extraordinary things, but the clustering of anomalies around this single object, the timing of its arrival, the coherence of its trajectory, the mass beyond expectation, the chemistry beyond precedent together, they formed a pattern too intricate to dismiss lightly. For Loeb, the calculations were not about threat but about understanding. If 3I Atlas were merely a natural wanderer, then its existence could force a rewrite of our models of planetary formation. If it was something more, a probe, a relic, a vehicle, a messenger, then the universe was larger and more inhabited than we have dared to assume. Either path points toward humility, the kind that makes even seasoned scientists pause at the window late at night, staring into the dark and wondering how much of reality we have yet to uncover. As days passed without new data, the collective imagination of the scientific world entered a rare state. Not speculation, not fear, but a kind of cosmic meditation. The absence of information invited reflection rather than panic. What does it mean to witness something that transcends our assumptions? How many frameworks do we cling to simply because they comfort us? And how often does the universe quietly challenge those frameworks, offering new truths only to those willing to see them? In this silence, one thought settled gently over the scientific community. The universe is not obligated to be simple. It is not required to be intuitive. and occasionally it reminds us of this with an object like 3i Atlas, something that refuses category, that resists explanation, that teaches by existing. When the object finally emerges from behind the sun, the sky will deliver its answers in the language of light and motion. Until then, all we can do is wait. And perhaps that waiting is not an inconvenience, but a gift, a moment to breathe, to wonder, and to appreciate the fragile intelligence that allows us to ask these questions at all. Rest now, traveller. The universe continues its quiet work. And somewhere in that brilliance behind the sun, 3i Atlas carries on its ancient wordless journey. When 3i Atlas slipped behind the sun, the scientific world entered a strange kind of quiet. Not a pause in activity, telescopes were still pointed models still running, but a pause in clarity. For the first time, the object existed beyond every instrument we had. That absence created a rare emotional landscape in astronomy, one where curiosity and helplessness coexisted. We were watching something extraordinary, yet unable to see it at all. And in that blindness, the universe reminded us that observation is a privilege, not a guarantee. During this blackout, scientists found themselves circling back to the object's contradictions. The mass was too large, the chemistry too inverted, the polarization too extreme. Nothing seemed to align with the known categories of comet behavior. These anomalies had been unsettling enough when we could see the object. But now, hidden behind the sun's brilliance, they grew even more haunting, like clues left on a table after the one who placed them has stepped briefly out of the room. Because of this, perihelion became a philosophical moment as much as a scientific one. What does an object reveal about itself when exposed to the most intense heat and radiation it will ever endure? Natural comets often fracture, brighten, or dissolve entirely, but 3i Atlas felt different, heavier in both physical mass and conceptual weight. No one knew whether it would erupt into fragments or pass through unscathed. The uncertainty carried a quiet tension, yet it also carried a kind of beauty, the beauty of not knowing and of being humble enough to wait. Some astronomers could not help but recall the wow signal of 1977 as that single anomalous whisper from deep space. It resurfaced in late-night conversations because the alignment was too poetic to ignore. A mysterious signal from nearly 50 years ago, and now a mysterious visitor passing behind the sun, each leaving just enough ambiguity to spark imagination without surrendering to fantasy. It reminded scientists that cosmic mysteries rarely arrive in tidy packages. They often arrive as fragments scattered across decades. While the object was hidden, models became our only means of vision. Simulations traced thousands of possible return trajectories, each one offering a different future. Some predicted a brighter, more active object emerging on the far side of the sun. Others predicted fragmentation. A few explored darker possibilities that the object might decelerate shift direction or release smaller bodies during the blackout. These were not sensational ideas, only mathematical ones. But mathematics sometimes opens doors that instinct prefers to leave closed. In parallel, the Galileo project refined its observational protocols, not because anyone expected anything dramatic, but because readiness is the quiet backbone of science. If 3i Atlas were purely natural, perihelion would be uneventful beyond thermal stress. Yet if it were something more, an engineered object, a carrier, or even a relic capable of shedding components, this would be the time to observe unusual motion near Earth. Preparing for that possibility was not fear-driven, it was simply responsible, curious, and open-minded. As the days of invisibility stretched on, a softer question began to rise beneath the scientific calculations. Why do we respond to certain cosmic objects with wonder rather than fear? Perhaps because they remind us of our fragility without threatening it. 3. Atlas had never been an object of panic. It had been an invitation to question, to imagine, to observe with humility. Even its anomalies felt more like riddles than warnings, like pages from a book whose author remains unknown. In the final days before its expected re-emergence, anticipation settled into a kind of collective meditation. Scientists across continents waited for the first faint pixel of the object to appear on their screens. Amateur astronomers prepared their telescopes, adjusting mounts and sharpening tracking software. The quiet unity of that waiting was its own phenomenon, Thousands of people holding their breath for the return of something that did not belong to Earth yet had somehow become part of its story. When the universe hides something behind the sun, it feels almost symbolic. A reminder that even in a range of instruments, there are moments when we must simply trust the unfolding of celestial mechanics. We cannot rush the cosmos. We cannot demand revelation. We can only stay awake to the possibility that what emerges may change our understanding, whether by confirming a natural explanation or by deepening the mystery. And so, Traveller, this chapter ends not with a conclusion, but with a posture of waiting, wondering, and remaining open. For even now, as Three-Eye Atlas passes through the brightest region of sky, we cannot penetrate, it continues its silent journey. Whether it emerges familiar or transformed, ordinary or unprecedented, it carries with it the quiet promise that the universe still has stories left to tell. Rest with that thought, observer. Not everything hidden is dangerous. Sometimes the universe simply asks us to be patient, to breathe, and to let the unknown unfold in its own time. When the first hour of the blackout passed, nothing changed. But when the first day passed, something subtle began to shift in the minds of those watching the sky. It wasn't fear, and it wasn't excitement. It was something gentler, something quieter. The sense that we were living through a rare moment when the universe asked us to pause, to look inward, and to recognise how small we really are against the canvas of light and shadow surrounding our sun. The disappearance of Three-Eye Atlas was temporary, but the feelings it evoked were not. They belonged to that ancient human instinct that looks at an empty sky and wonders what might be hiding behind the glare. While Earth rotated through its familiar rhythms, research teams gathered in quiet rooms lit by the glow of computer screens. They revisited every frame captured before the blackout, searching for patterns they might have missed. Some found nothing new, some found hints worth investigating, and a few discovered small, unexplained deviations in brightness or structure not enough to draw conclusions, but enough to whisper that the object's final hours before perihelion had been active, perhaps even turbulent. But without observational confirmation, every hint remained suspended, waiting for its counterpart on the other side of the sun. At the same time, others turned their attention to the data collected by spacecraft farther from the glare. Juice Lucy and Europa Clipper each had opportunities to glimpse the object at wide angles before it vanished completely. Their data would take weeks or months to return to Earth, delayed by distance and the slowness of communication windows. And so the information rushed outward into space, but trickled back slowly like ripples, eventually returning to shore. In those delays, the scientific world felt the weight of cosmic scale more deeply than usual. Space is not just large, it is patient. Meanwhile, the public remained dimly aware of the event. Headlines appeared briefly, then dissolved beneath the usual currents of news. But a smaller group, the listeners, the stargazers, the quiet observers, watched more closely. They asked themselves what it meant for something older than civilization to pass behind the sun unseen but not forgotten. They wondered whether it would be the same object when it reappeared, or whether the sun itself might change it in ways our theories could not predict. And in that wondering, a new kind of awareness formed, the awareness that reality, no matter how carefully measured, always contains territory beyond our maps. For astronomers, the deepest question was not what Three-Eye Atlas was made of, but what it was doing. Natural objects have patterns, predictable if sometimes complex. They brighten, they fragment, they accelerate slightly from jets of gas. But because Three-Eye Atlas defied many of these expectations, the blackout became a kind of cosmic interrogation chamber. What would the sun reveal? Would thermal stress expose weaknesses in its nucleus? Or would the object drift through the furnace untouched, as if built or consolidated by forces entirely unfamiliar to our understanding? Some simulations predicted intense fragmentation. Others predicted a dramatic brightening event. A few predicted a nearly unchanged return, a scenario that many scientists quietly hoped for simply because it would preserve the object long enough for deeper study. Yet, among all these possibilities, one scenario felt the most emotionally charged, though it remained the least discussed, the scenario in which the object reappeared on a trajectory slightly altered even by a fraction of a degree. A tiny shift would mean everything. It would mean the object responded to forces beyond thermal expansion or gas jets. it would suggest intention, or at least complexity, of a kind we do not yet understand. But intention is not a word scientists use lightly, and so no one spoke it directly. They circled the idea instead, examining it from angles that felt safer: subtle gravitational influences, errors in measurement, perturbations from dust or solar wind. Yet all the while the feeling remained, the idea remained. If 3 Higher Atlas were merely a comet, it was the most unusual one ever found. And if it were not, then the universe was wider, stranger, and more inhabited than our textbooks allow. During these days of uncertainty, another quiet realization emerged. Humanity often assumes itself to be the subject of cosmic events. But watching 3i Atlas pass behind the sun, invisible and indifferent, reminded many that we are not the centre of anything. We are spectators, observers, a species still learning to read the faint handwriting of the stars. The blackout humbled us not through fear, but through perspective. It showed how dependent we are on light, how fragile our instruments are, how easily a single arc of brightness can blind us. Blind. And in that fragility we discovered a kind of beauty. Somewhere across the world, night by night, amateur astronomers continued to gather under the sky. They knew they would not see the object, but they looked anyway, not for data, but for connection. To watch the empty space where something extraordinary was passing is a different kind of observation, one that speaks to the oldest parts of human imagination. It is the same instinct that guided ancient sailors, desert travellers and mountain monks. The instinct to gaze upward and feel the quiet vibration of the unknown. On the scientific side, teams finalised the list of diagnostic features to check once the object re-emerged. Spectral shifts, surface changes, jet structures, coma geometry, rotational light curves, and above all else trajectory, because trajectory carries truth. Light can mislead, gas can shift, even chemistry can surprise. But motion reveals the soul of an object. A comet that follows gravity alone has one kind of story. An object that alters course behind the sun carries another. As the final days of invisibility approached their end, a soft sense of anticipation grew not dramatic, not fearful, but reflective. If the universe wished to remind us that not everything must be known immediately, this blackout had succeeded. If it wished to awaken our curiosity without overwhelming us, it had done that too. And if 3i Atlas had any intention at all, the sun had become its curtain, shielding its next act, until the precise moment of revelation. What awaited us on the far side was unknown, but the unknown traveller is where wonder lives, and sometimes the universe asks us to rest in that wonder quietly, humbly, until the light returns. When the first photon arrives again from the object, everything will change, or nothing will. Both possibilities are profound. Both are gifts. And until then, all we can do is breathe, thus observe the darkness and wait for the cosmos to speak again. When the first faint signals from the far side of the sun began to reach Earth again, they did not carry images or spectra. They carried timing, the simplest form of truth. Observatories knew roughly when 3i Atlas should reappear, but the sun's brilliance made the boundary between invisibility and visibility uncertain. And so scientists waited, studying the moment when data shifted from noise to pattern, from emptiness to the subtle presence of something moving at 60 kilometers per second. It was not yet a picture, not yet a shape, only a tremor in the flow of light. But for those who had waited through the blackout, even that tremor felt like the universe whispering, "It is returning." Before the first photograph appeared, teams around the world ran last-minute checks on their instruments, as if preparing for a long-awaited guest. No one expected a dramatic transformation. They simply hoped the object had survived. But deep down, many carried a quieter hope that the re-emergence would reveal something new, something that would either settle the months of speculation or deepen them in a way that invited further exploration. Curiosity, after all, is not a search for certainty. It is a willingness to be surprised. In the meantime, theoretical models remained the only source of guidance. Some predicted that 3i Atlas would brighten, having shed its outer layer during perihelion. Others predicted a dimming if volatile material had been burned off. A few models, built on the assumption of artificial structure or mass consolidation, predicted almost no change at all. Each model represented a worldview, a quiet declaration about what kind of universe we believe we live in. The blackout had become a mirror, showing not the object, but the assumptions of those who studied it. As hours passed and no clear detection appeared, doubts began to ripple quietly through research centres. Had the object fragmented behind the sun? Had intense solar heating torn it into dust too faint to detect? The possibility lingered not as fear, but as melancholy. A fragmenting comet is a natural thing. Many do so every year. But losing the most enigmatic interstellar visitor ever detected would have felt like losing the middle chapter of a book we were only beginning to read. Somewhere between optimism and resignation, the first low-resolution thermal signature appeared. It came not from Earth, but from a spacecraft positioned far from the Sun-Earth line where glare was reduced. The detection was weak, almost drowned by noise, yet unmistakable, a warm object moving in the predicted region of space. And in that instant, global uncertainty softened. 3I Atlas had survived perihelion. It was still there, still moving, still carrying its silence across the inner solar system, like a lantern drifting through the dark. But survival was only the first answer. The deeper questions lay in what the object had become. The first optical image arrived hours later, captured by a wide-field telescope in South America. Even blurred, even distorted, it revealed something strange. The coma appeared asymmetric, not in the direction of motion, but in a direction angled sharply away from it. This was not the forward jet anomaly seen before. It was something new, a faint plume extending diagonally as if the object had shed material in a burst during perihelion. The plume did not resemble a normal dust tail. It was too thin, too straight, too coherent, like a thread drawn across space. Researchers immediately began debating its meaning. Was it a jet of gas exposed by solar heating? A fragment that had broken away? Or something more structured? With only a single image, no answer could be definitive. Yet the presence of the plume indicated that 3I Atlas had experienced a significant event behind the sun, a moment of activity or stress that left a visible scar. As additional images arrived, a pattern began to emerge. The plume was fading quickly while the nucleus remained bright and intact. Fragmentation, if it had occurred, was minimal. This alone was extraordinary. A comet enduring perihelion so close without breaking apart challenged expectations. But challenging expectations had become the signature of this object. It was no longer surprising, though still deeply mysterious. Spectroscopy followed next, though limited by early timing and low signal strength. The most notable feature was not a new chemical species, but the persistence of carbon dioxide dominance. Despite the immense heat of perihelion, despite the potential for deep structural exposure, water emission remained faint. Carbon monoxide had increased slightly, but not to the degree predicted. Once again, the object held onto its strangeness, as if its internal structure were revealing itself reluctantly layer by layer. But the most important measurement the one scientist had waited for most anxiously was trajectory. Would the object pass through perihelion along the exact gravitational path predicted? Or would it emerge with the slightest alteration, a shift too deliberate to ignore? The answer arrived slowly over 12 hours of triangulated observation. At first, the data seemed reassuring. The object's position fell within the expected corridor, but as more readings accumulated, a small divergence appeared subtle, almost insignificant, yet real. A shift of tens of kilometers, then hundreds, then more. Not enough to indicate propulsion, but enough to indicate a force acting unevenly on the nucleus during perihelion. Natural explanations existed: asymmetric heating, directional mass loss, surface collapse, but none matched the observed drift perfectly. The deviation was smooth, continuous, and oriented in a direction not aligned with any predicted jet structure. It was as if the object experienced a gentle, sustained push from within, quiet, controlled, intentional only in the mathematical sense. When the deviation was confirmed independently by 3 observatories, a soft unease settled over the scientific world. Not fear, not alarm, just the awareness that something unusual had happened while we were blind. something that left no obvious trace, no dramatic display, only a delicate fingerprint pressed into the object's path. And so closes not with a revelation, but with a deeper mystery. Three-Eye Atlas had gone behind the sun and come out changed, slightly subtly, but undeniably. It was still itself, yet no longer the same. Perhaps this is the nature of all journeys through fire. Perhaps perihelion does not destroy but transforms, or perhaps the change was born of mechanisms we do not yet understand. For now, Traveller the Sky has begun speaking again, and the object continues its silent glide toward the next chapter of its passage through our system. Whatever waits on the other side, we will meet it with the same mixture of curiosity, humility, and wonder that has guided humanity through every cosmic question. In the days that followed the object's reappearance, the scientific world shifted from anticipation to scrutiny. Everyone understood that the next phase would be slower, more deliberate, more analytical. The immediate questions had been answered. Three-Eye Atlas had survived perihelion, and it had changed. But now subtler questions emerged like dust settling after a distant impact. What changed? How deeply, and perhaps most quietly of all, why? The first high-resolution images came from a network of telescopes in Chile, where the dry air and dark skies revealed details that early observers could not. In these images, the nucleus appeared slightly elongated, almost as if a thin ridge had formed or been exposed during the solar encounter. It wasn't a fracture, not a split, but a contour that had not been visible before. A shadow line suggested a depression or cavity near the sunward hemisphere. This small structural alteration became the seed of many debates. Was it erosion? Was it collapse? Or was it an aperture? A feature that had always been there, simply waiting for the right angle of a light. As the images multiplied, astronomers noticed something else. The rotation period had shifted. Only by minutes, but minutes mattered. For an object weighing tens of billions of tons, such a change could not be dismissed as trivial. Rotation changes require torque, the kind produced by asymmetric jets, internal mass redistribution, or structural adjustments. The data suggested the change was smooth and continuous, not abrupt. That alone made it unusual. Natural fragmentation causes sudden jumps, not gentle drifts. Something had acted on the object consistently during the blackout, and whatever it was left a subtle but measurable imprint. Spectroscopic readings soon followed, and with them came another surprise. The carbon dioxide signature was stronger than before, not dramatically but noticeably. One interpretation suggested new fissures had opened, exposing deeper layers rich in frozen CO2. Another proposed the thermal stress had activated pockets of volatile material previously insulated by dust. But these explanations carried an underlying assumption that the object was layered in familiar ways. Increasingly, that assumption felt fragile. For every new measurement, two theories blossomed, one grounded in known physics, one reaching into possibility. But both remained tethered to the object's silence. Silence, after all, is also data, and Three-Eye Atlas spoke through what it withheld as much as through what it revealed. During this time, trajectory models were refined hourly. Each new coordinate sharpened the picture of the perihelion drift. The deviation remained small, yet exacting in its smoothness. Its direction was neither aligned with a solar wind nor with known exhaust patterns of comets. It was offset in a way that suggested orchestrated release of internal material, though not at a level that implied propulsion. It was like watching a gigantic stone being nudged by a whisper. As the drift pattern persisted, some astronomers suggested the object's internal structure might be porous in unusual ways. Perhaps pockets of CO2, when heated, vented through complex tunnels carved by billions of years of cosmic radiation. These vents, if angled, could theoretically produce the observed vector. Others proposed a more exotic idea, that the object contained voids or masses arranged asymmetrically, and that solar heating shifted internal stresses in ways we do not yet understand. These ideas were not sensational, merely thoughtful attempts to reconcile anomaly with natural law. But a separate question hovered quietly behind all the others. If Three-Eye Atlas had been shaped in a star system unlike ours, what would its internal architecture look like? Would we recognize it at all? Or would its chemistry and structure reflect evolutionary histories we have never modelled, shaped by pressures and temperatures no human instrument has yet simulated? Meanwhile, amateur observers contributed in their own way. Their telescopes, though smaller, captured more frequent images. This high cadence revealed subtle brightness fluctuations the large observatories missed. Some nights the object brightened in a narrow band of wavelengths, only to dim again the next night. These pulses were too faint to constitute signals, yet too rhythmic to dismiss as noise. They resembled a heartbeat, weak, irregular, but present. Scientists cautioned against interpretation, reminding themselves and everyone else that comets experience sporadic outgassing. Yet privately, a few admitted the pattern made them uneasy, not because it suggested intention, but because it suggested we were witnessing processes unfamiliar even to the most seasoned comet researchers. Across the ocean of speculation, the Galileo project remained steady. Their wide-field instruments scanned Earth's sky for fast-moving anomalies, not in hope, not in fear, but in duty. If perihelion had triggered anything unusual, Earth's atmosphere might eventually feel the consequences, but the early results showed nothing. Clear skies, ordinary satellites, a quiet dome of stars. And in that quiet, the science teams allowed themselves a rare moment of relief. In parallel, planetary scientists revisited old questions with new urgency. If interstellar objects like 3I Atlas are more diverse and massive than models predict, how many have we missed? How many passed through the solar system in the centuries when no one was watching? How many came close to Earth long before telescopes existed? And how might these ancient wanderers have shaped Earth's geological or biological history in ways we have not yet imagined? The deeper truth was becoming harder to ignore. 3I Atlas was not just an anomaly. It was a teacher one whose lessons were written in contradictions. It showed us how incomplete our models are, how narrow our expectations can be, and how vast the cosmic laboratory truly is. As the object continued its outbound trajectory, gaining distance from the Sun, and slipping into darker regions of sky scientists prepared for the next phase high-resolution composition mapping. This would require weeks of coordinated observation. But even before these results arrived, one thing had become clear: we are still standing at the threshold of understanding, not inside it. And so this chapter ends with a feeling both unsettling and peaceful. The object has survived, changed, and continued onward. We have learned much, yet touched only the surface. And somewhere inside 3I Atlas, beneath its carbon dioxide crust, beneath its anomalous dust, beneath the silence it carries, lies a history far older than Earth's continents, waiting for someone someday to unravel it. Until then, observer, we stay patient. Some mysteries are meant to be followed, not solved. And the universe, in its quiet wisdom, knows exactly when to reveal the next piece. From the moment 3I Atlas settled into its post-perihelion path, the scientific world felt a change in the air. It was not dramatic, not loud, but subtle, a shift in tone, like a room that becomes quieter without anyone knowing why. The object had survived the Sun. It had emerged intact. But something in its movement hinted that the story had entered a new phase, one less defined by spectacle and more by introspection. Researchers sensed that the most profound lessons might come not from dramatic events, but from the quiet details now unfolding. The first observations focused on the object's motion, because motion more than brightness or colour reveals intention, or at least the appearance of intention. After 3I Atlas re-entered visible space, its trajectory stabilised into a slightly altered path. The deviation was gentle, but too clean to ignore. It did not wobble the way a comet should after shedding material. It did not drift asymmetrically. Instead, it traced a smooth arc that suggested a consistent force acting across the object's surface during the blackout. Natural explanations existed, yet each felt incomplete, as if missing a hidden variable. Scientists revisited their simulations, adjusting parameters for internal venting, thermal expansion, and rotational drift. But no model reproduced the precise behaviour observed. The data resisted assimilation not aggressively but politely, as if holding its own shape despite every attempt to mould it into familiar patterns. Some researchers felt frustration, others felt awe, and a few felt something else entirely, the quiet suspicion that the object's history was richer than anything our models had anticipated. Brightness variations continued to offer clues. The oscillations were faint, soft pulses of light rising and falling, as if the object were regulating its own temperature after the intense heat of perihelion. These fluctuations were consistent enough to track, yet inconsistent enough to defy a single explanation. In some wavelengths, the object brightened evenly. In others, the light flickered with a strange restraint, like the glow of embers settling under wind. No one mistook these variations for signals they did not have the structure or precision for that, but everyone recognized them as expressions of change. As the light curves accumulated, organic molecules appeared in the spectra, faint but undeniable. Their presence prompted careful reanalysis. These were simple organics, but still far more abundant than earlier measurements suggested. Some researchers concluded that perihelion had exposed deeper layers. Others proposed that heating may have triggered chemical reactions on the surface. Either explanation hinted at complexity, a reminder that interstellar chemistry operates across timescales too vast for intuition to grasp. The organics opened a philosophical doorway. If the object had carried these compounds across light years of empty space, what stories did they represent? Were they remnants of a long, vanished planetary system, byproducts of unknown stellar chemistry, or fragments of something older than any world we have mapped? Scientists knew these questions were speculative, yet they felt natural. Curiosity is not an indulgence, it is humanity's way of honouring the unknown. Trajectory data, however, remained the most enigmatic element. The object had shifted slightly during the blackout, but the direction of the shift did not align with expected forces. It was not consistent with solar wind pressure. It was not consistent with the geometry of outgassing jets. It was not aligned with rotational vectors. Instead, it pointed along a diagonal that felt both improbable and strangely graceful. Some scientists suggested internal cavities releasing gas in a directed stream. Others invoked the possibility of large-scale structural transitions under heat. These explanations remained grounded in natural physics, but each required assumptions that stretched the boundaries of known cometary behaviour. Nothing about 3I Atlas had ever fit easily into existing categories, and this new anomaly continued the pattern. And so the object became a mirror again, reflecting not the universe, but the limits of human expectation. For decades, scientists believed interstellar visitors would resemble comets from our own system. But the galaxy is older, larger, and stranger than our small sphere of experience. Why should its travellers conform to our intuition? Why should their chemistry, structure, or history resemble ours? 3I Atlas invited a reconsideration not only of comets, but of cosmic diversity itself. The question began to circulate quietly. Had humanity underestimated the variety of objects roaming between stars? If 3 interstellar visitors had appeared in just a few years, all with unusual properties, what did that say about the unseen populations drifting through the galaxy? Perhaps interstellar space is not empty, but filled with fragments of countless worlds, icy bodies, metallic shards, frozen atmospheres, and ancient remnants of violent histories. In this picture, 3I Atlas was not strange. We were simply inexperienced. And yet, even within this broader perspective, 3I Atlas felt singular. Its mass alone placed it in a category of its own. Its resilience near the sun defied common sense. Its chemical inversion, carbon dioxide dominating while water retreated, suggested a birthplace radically different from our solar nursery. These qualities made it feel less like a random interstellar wanderer and more like a curated artifact of cosmic evolution. This did not imply artificiality, but it did imply uniqueness. As it drifted outward, the object began to dim, slipping slowly away from easy detection. The coma thinned, the plume faded, and the nucleus receded into the cold. Observatories extended exposure time, stretched their capabilities, and worked long nights to capture the last clear images. Every pixel mattered. Every change mattered. They knew that soon the object would cross the threshold beyond which Earth's instruments could no longer follow. In these final weeks of clarity, a quiet melancholy settled over the scientific world. Not a sadness born of loss, but a softness, the feeling that a rare encounter was nearing its end. When 3i Atlas eventually slipped into the deep regions of heliocentric night, it would continue its journey without us carrying whatever secrets it possessed back toward the dark it had come from. But the encounter had already changed something. It had expanded the boundaries of what scientists were willing to imagine. It had humbled our assumptions. It had shown that even in an age of advanced instruments and precise models, the universe still holds surprises large enough to shake our understanding gently, without violence, without spectacle, just through the quiet persistence of anomaly. And perhaps that is the true meaning of 3i Atlas, not that it is artificial, not that it is dangerous, not that it is a message, but that it is a reminder that the cosmos is vast, that our knowledge is young, that the unknown is not a threat but a companion. And so this chapter closes with the awareness that mystery itself is a kind of grace. Not everything must be solved. Some things exist simply to widen our vision, to deepen our humility, and to remind us that wonder is not a childish response, it is an honest one. And so, traveller, our journey settles into its quiet ending. We've drifted together through strange images from Mars and through the silent questions left behind by 3i Atlas. These first glimpses don't resolve anything. They simply widen the mystery, reminding us that the universe still thinks in patterns far older and gentler than our instruments can follow. You chose to walk that uncertainty without needing answers to listen, instead of fear. And that is its own form of courage beneath the stars. Whatever Triatlas truly is, visitor echo or silent fragment from a forgotten system, it continues on indifferent to our theories, yet somehow reshaping the way we see the sky. As this chapter closes, hold one truth close: the cosmos is still alive, still whispering, still unfolding in ways we can barely comprehend. Rest well, traveller. Stay curious, and let the universe keep watch tonight.